To developers or programmers circle, we have Python described as programmers earning to homestead are no sphere. Not all roots are buried under down in the ground, some are at the top of tree. Welcome to Coders 331. I'm Shalini here. Thank you all for looking at today's session. I'm looking forward to talking with you today all about a Sudoku GUI solver. Yes, you listened it correctly, Sudoku. The mysterious game of India also comes in the newspaper to solve it out. There are two ways to write error-free programs. Only the third one works. Looking around all GUIs hurrying to a Sudoku GUI, revolve and have a look at what we'll be talking about. What a project is all about, or what we'll be discussing about today is what project is all about, what Python. I'll give you a short descripted concept about it, GUI, what is algorithm, or you can say algorithms introduction. We'll be discussing about backtracking algorithm, what we have used in this GUI, what applications we have, mainly the complexity, the algorithm we used out, what its complexity is and how we'll be finding that, and obviously the program, the main concept of our GUI on which the whole is based on. So we'll be starting with that what exactly a project is. It is Sudoku GUI solver, and this GUI is a Sudoku Python program that uses backtracking algorithm, and this program is all written in Python language. The algorithm we used here is backtracking. What projects start within Python is that the libraries, what we'll be discussing about, the libraries I used are PYGAME and the time library. I've been importing them, extracting the packages and using them in my program. Then what we did is we created a 9 into 9 grid along with rows and columns and forming checkboxes. Now, GUI is a Sudoku solver. What it all eclipses out of box or Sudoku. In rhythm, let's discuss about Sudoku. What is Sudoku actually? Sudoku is a logical based combinatorial number placement puzzle. It means that you have to place numbers in that puzzle and you have to frame out a rectangular box filled with numbers, and then you check up with the answers. What it's all about, what is its objective basically? Objective of Sudoku is to fill that 9 into 9 grid with digits so that each column, each row, and the line of subgrids compose the grid, and that grid consists of digits actually. That grid consists of digits from 1 to 9, and the puzzle setter would partially complete that grid. That forms a well posed puzzle, and it has a single solution only. That is, completed games are actually always an example of Latin square, which include an additional constraint or contents of individual region. It means that the same integer may not appear twice in same row or same column or any of 9 sub-regions of 3 into 3 grid while playing. We have variations also for this. What variations we have is that, one more thing I want to tell you here is that the relationship between two theories is known after it is proven that first order formula. So, the formula we apply for these 3 into 3 subgrids is known as first order formula, and that is not valid. Actually, that is not mentioned in the blocks for Sudoku if and only if Latin squares are valid. Then what happens is, one major note I want here to discuss is that Le France in 1895 refined puzzle so that it was almost a modern Sudoku. It simplified this 9 into 9 magic square puzzle to each row, column, and broken diagonals contained only if the number 1 to 9 but did not mark the subsequent. Okay, now we'll be discussing that many of computer algorithms just like backtracking and more algorithms like dancing links can solve 9 into 9 puzzles efficiently. But if we talk about explosion, combinatorial explosions, then the number will increase that limits the properties of Sudoku, and that can be analyzed and solved as n increases. Yes, if we talk about that Sudoku puzzle, how it can be expressed as, actually it can be also expressed as a graph coloring problem, and the graph coloring problem is also to color a particular graph given a partial 9 coloring. You are provided with 9 coloring. In Sudoku also we have 9 into 9 puzzles that are divided into 3 into 3 subgroups. Similarly for graph coloring we have 9 coloring of a particular graph. We are given with a partial 9 coloring graph. Hope you do understand this. Now we'll be actually discussing about GUI, that is the graphical user interface. What GUI is all about basically. We'll be starting up with that GUI is something that interact with icons and cursors and come out with some valuable information. So GUI is more user friendly than CUI. It interacts with different electronics devices. GUI is basically a programming interface that takes advantage of computer graphics and make it easier for us the users. GUI actually display objects that convey info and represent actions that can be taken by users. Okay, this is basically the what I need to discuss about. I'll be telling you it through a diagram. That is, we have user, we have GUI, then we have a display server, and then kernel, and then hardware. What happens is when we turn on our GUI, GUI is also our MS, also is our GUI. Whenever we open PowerPoint or Excel, we get into an interface that is basically a GUI. We get that interface as a display server, and where this display server is reaching to us from, that is from kernel, and kernel is contacting whom? Hardware. Hardware is being contracted for being there into a GUI or displaying that. If there's trick to it, the UI is broken. Okay. What it means is that if there is a trick for GUI, then obviously your GUI is broken. The three great virtues of a programmer is basically laziness, impatience, and excessive pride, as if the programming is not about with what we know. It's about what we can figure out. A server side developing scripting language. Yes, I'm talking about Python. What out? Now let's revolve around Python, in which our whole GUI is made up. And let's discuss without wasting a second what it's all. Python, the fastest growing language. Why I said that it is the fastest growing language? It is fastest growing language in terms of the companies who are using it, and obviously the libraries which it consists of, and yeah, doing with support procedural and programming too. So Python is basically a popular programming language because it firstly it came into 1991 into the picture, and it made it very easy for the programmers as well as developers to reach out code, and we haven't been organizing or our works and searching our works very easily, just like we need to sort any list. Do we need to write an algorithm or program for it? No, we have an inbuilt function for sorting in Python. So it is having the number of libraries which make our work easier, our lines of code perceived. It is used for web development from for server side software development as well. In mathematics also it can be used out because it has inbuilt library for mathematics as well as system scripting. When I do talk about that, why what Python is all about, what it can do. Python is basically a programming language, or you can say procedural programming language, also an object oriented programming language. It can act as a server to create web applications. It can also create workflows. It can handle big data and perform complex mathematics. It is also used in data science, machine learning, AI, and for all these three concepts which we learn all together, or one by one along with each other are used or are based basically on Python. Python is the most prominent language for all these three: data science or big data and performing complex mathematics. Python can be used for a prototyping or production ready software development also. If I to come on why Python, why I should prefer Python or why I should use Python because it works on different platforms. It can work on multiple platforms. It can work on Windows, it can also work on your Mac, Linux, and also Raspberry Pi. Next is that it is an interpreter system, that is, as you write the code, as quickly it gives out or brings out you the output. The three major outputs or advantages I have for Python is that its syntax is similar to English language. It can work on different platforms and it is very easy to learn. Okay. Yeah, it is actually very easy to learn. Coming on to what is basically algorithm. We'll be discussing about algorithm. Set of rules to obtain expected output from a given input is actually algorithm. It is an idealized recipe to carry out programs. No more than recursive calling here, we define an algorithm, the use of which makes UI colorful and crispy. Algorithm along with will be defined how a work is done. Algorithm is basically a language independent and it leads to clear and one meaning. Then if I talk on more about algorithm, we move to its characteristics. What all about characteristic of an algorithm? The first characteristic we discuss about is well-defined inputs. Well-defined inputs means that you should have concise input and they should lead to one meaning. Well-defined outputs. What about outputs that they should lead to a one concise output? Finiteness. Finiteness is all about that your algorithm should not have infinite number of loops. Feasible. Algorithm must be practical and it should be simple. Feasible here also means that it should not have any future extension or the technology that is being used in the future. Language independent. It is a plain instruction. You can execute it anywhere. It's not mentioned that you have to write an algorithm in C only or Python only, then it will only run. No, it's a language independent. You can write it on any IDE, any software, any console, any terminal. Clear and ambiguous. Yes, it means that steps should be all clear and aspects and they should all lead to one meaning in now it comes about that which algorithm or what we have used in our GUI, what all it revolves around, what we are using actually. Additional way to solve a problem says backtracking algorithm. We have used here the backtracking algorithm. Backtracking algorithm says that it is an additional way to solve a problem. Actually, what is backtracking, why we are using it, and how we are using it, we'll be discussing in this session. Backtracking is a problem solving strategy which uses brute force approach. It is an algorithmic method to solve a problem with an additional way. So it is basically a recursive approach to explain the problems. Okay, it's actually used when we have multiple solutions and we want all those solutions. Means if we have four solutions to a single problem, we want all those four solutions to our problem. It's depth for search with any bounding function. It's an important tool for solving constraint satisfaction problems such as Sudoku. And the reason here I use backtracking is the same, that it becomes an important tool when we have multiple solutions and also when we have to solve out a constraint satisfaction problem. Here also I mentioned that backtracking is a systematic way of trying out different sequences of decisions until we find the one that works. Backtracking is something like this. Backtracking is a depth first search that has many bounding functions. What happens if you start from here move to another point. From that another point also you can go anywhere, but you have to find the point where you have no dead ends, and the point from where you can recursively come back and trace your path once again. That is the point where you can get a success. All solution using backtracking is needed to satisfy a complex set of constraints. As I told you that obviously we use backtracking for solving out our constraint satisfaction problems. I have drawn out here a picture that is parent and it has three children. You can also represent as parent those are having three children. The next thing we learn about is there are two types of constraints, the explicit constraint and the implicit constraint. When we talk about explicit constraint is the one that restricts vector element to be chosen from a given set. An implicit one is that define tuples in solution space that actually satisfy the criteria. You can see that is the green one is a root node, the pink one are the internal nodes, and the orange one are the leaf nodes. So what happens is from the green we are moving to two pink, but one pink has a dead and the another pink has various solutions from where we can move on. This is all about basically the backtracking algorithm. If I talk about applications, what applications can be rather than Sudoku? The one we discussed before, graph coloring, where we have 9 partial colors to discuss about. Now, the most basic thing what we'll be discussing about is applications. What applications we have rather than Sudoku? What can be other applications of Sudoku too? Puzzles such as 8 queen puzzle, crosswords, verbal, arithmetic, and peg solitaire are also its applications or types, you can say. Combinatorial optimization problems such as passing and the knapsack problem are also its type, and the complexity finding applications. One more thing is that logic programming languages such as Prolog, backtracking internally to generate answers. PS, Prolog, and Planner do also use backtracking for generating the answers. One more thing is that along with backtracking, we have another concept that is a naive algorithm. What is we'll be discussing about naive algorithm in another session, but yes, a line glimpse for that is that it generates all possible configuration of numbers from 1 to 9 to fill empty cells. What happens when we solve about crossword puzzles? What we have a grid of 1 to 9 cells. We need to find solution for every of them. So naive algorithm what this does, it do get or generate a configuration for filling those 9 empty cells. Now the point around which the ring is formed. Yes, the complexity of this whole GUI, what we have made and discussed till now. Complexity is basically the defining the exponentials or finding out how much time it has been taken to solve out or prepare an algorithm for all this program. If you're using backtracking, complexity is exponential. That is for every move taken. If we talk about other way, what happens is O is basically the order n raised to m. N, what n is describing here is the possibility for each square, and m is the blank spaces. Algorithm is obviously using therefore search for all solutions, and the graph I showed you, it represents the choice of a single square. Depth of graph is number of squares that are to be filled. So what we do here is what we apply a branching factor of n and compute depth of m and find a solution for all this. So from this what we get is that worst case for this is n raised to the power m, that is order is n raised to the power m. But if we talk about only the complexity, we cannot find out for backtracking, and it is something exponential and it's complex to find out. what about all what about all program is this? I have this game sudo py actually. Py is the extension for Python. I'll be explaining you this program one by one, what I did and how I did formed out this sudo. We start with forming a grid by importing out in libraries. I started by importing out Pygame and time library. What Pygame is all about? Pygame is a Python wrapper module for STL multimedia library. And similarly, for time, what we have is that time function returns number of seconds that have been passed. Okay, now here I boarded out or drawed out a grid that is named as board. You can count here that for every single row and for every single column we have 9 into 9 grid. Now what we have happens is I described out each and every self rows and columns along with width and height. I defined all this in a def function. What def is basically, first, I'll be explaining you what init and self is. What about why we have used it out here? Init and self. The init method self refers to the newly created object in other class methods. It refers to instance whose method was called. And init basically a reserved method in Python. In OPS programming, we call it as constructor. Init method can be called when an object is created from the class and access is required to initialize the attributes of class. If I talk about this def, what def is? It is a keyword that makes the function harder. It start the function header basically. Now once again representing self dot rows is equals to rows. What self is basically, it is representing instance of class, and what it is doing is it is binding two attributes with the given arguments. What it is binding the true attributes, and the arguments we are giving is rows. Similarly for columns and cubes, what I did is I drawed out cubes with the variables I and j, declaring the width and height, and providing columns a range and rows a range. That is 9 into 9. Then what I am doing, I have prepared out this model, a box like. What I'm doing is I'm updating it and setting it to win or lose. When it comes to discuss update model, we are again describing the range for the j and I integers, that is for columns and rows. Then we are declaring a variable that consists of the values, that is if we are setting cubes to row, we are setting row and column, and they're initializing the value from 0, that you have to start from 0 and set it to, and you can enter values in according to choice or whatever you apply, whatever algorithm you apply, either it's naive algorithm, constraint satisfaction problems, or either backtracking algorithm. Then we have drawn out a sketch. If we talk about sketch, what we have delayed out, or what we have sketched is that we drawed out strip of numbers of 9 into 9 along with row and column, and set it as a cube, and the temporary values are being set into them. Now we are drawing grid lines here, and what we are doing, for every grid line we are dividing the width by 9 and setting out the range. If we have discussed about range, then every what loops do is it goes in, check outs the range, and what it does, for every row it increases by 1. It says that we have to divide this into 3 into 3 subgrids. So what we do is moduli 3. If it comes out to be 0, then okay. If it don't come out to be 0, then its thickness will be set to 1. If it comes out to be 0, its thickness will be set to 4. Now importing library, and what we are doing, we are ranging it from, we are first of all declaring a gap between them and ranging it for win. Within the gap we have allotted for its width and thickness. Then it comes about cubes. Again, cubes are selected, rows and columns are being described, and range are being described here. Similarly, if the game is to be finished around rows and columns value are set to 0 and values are being return. If I satisfy range and j satisfy columns range, then you have to the value enters, otherwise it is being checked again and again. To solve this, what we have to do, we have to compare every previous entered number to the next one. If it is wrong field, we change that number. If it is right field, we do not change that number. Then for solving GUI, what we'll be doing that, for solving GUI, this is also a program. I've been here defining that. You can see in a cube rows we have 9 as well as columns are also 9. Its values are set, temporary values are set, and all are being set here. And then font is being extracted and declared here from PyGame. XY axes are being given here, text is being given here for every width. How to solve that? For every text we have a font style. For every the block we got, or we can see in a Sudoku, the every single block is given or x-axis and y-axis plot, as well as the range of values with height, everything. When we discuss about empty, what happens in empty, range and length both are described, because when we talk about list, we have to find it efficiently, where we use a term known as key. Every key is compared, or every index number is compared and filled out. This is all about program. If you want this program, you can text me or drop me a message or let me know in comment section. I'll be ready to help you out.